Okay, let's get into this technical stuff. Also, I guess I need to have a brief disclaimer here. Since I'm from EPA, I can't promote or whatever, any specific technologies or vendors. So any specific projects that I talk about today are just meant to be illustrative of the kinds of good projects and good work that people are doing. As Jeremy mentioned, and many of you have heard me speak at retail conferences and elsewhere, I was, and I still am, a big hammer guy. I'm a very strong proponent of in-situ thermal treatment. But I also have come to realize that what we're trying to do here is just not to knock the you-know-what out of the sources, but to actually close out the sites. So out of necessity, I've gotten more into combined remedies, and that's going to be the focus of my remarks today. Well, as far as I can tell, also every 2 years there's a big conference at Patel. Next year it's going to be in Palm Springs, but every time I go there'll be another incremental increase in the number of people who are using the right tools in the right situations. And that's certainly something that we'd like to continue to support and encourage. And it's been a marvelous opportunity to collaborate with the NGWA and with Jeremy and some other folks on our advisory panel to hold these kinds of workshops. But it is really true that different tools are most appropriate, depending on the contamination, its phase, its location, in the different compartments that are involved. And also, at our very first conference in Cambridge, we had a large panel in the afternoon because there was kind of this idea that maybe regulators were still part of the problem or somewhat reluctant. And we had people from my Region 1 office, both staff and supervisors, and people from the state of Massachusetts. And it became apparent that, at least at the 99th percentile, the regulators aren't part of the problem. If anything, we are receptive, and my colleague who will be speaking next from the state will reinforce this point, that as a general proposition, and again, I'd be interested, by the way, if any of you have contrary experiences, if you're having any problems getting regulators to consider the idea of using more than one technology. And I understand, at least on the surface, it makes life look more complicated. You got more oversight to do, more technologies to understand. If you have more than one contractor or consultant on site, there's all those issues of management and span of control. But as a general matter, we don't seem to be part of the problem. And also, again, the EPA, the fact that I'm standing here today, we are encouraging our RPMs and OSCs to incorporate combinations of tools in their decision documents. And again, despite what some people have thought, and despite the fact that the Superfund law is cumbersome legally and administratively, there's nothing in the law or the National Contingency Plan, the regulation which guides our implementation of remedies, from being not only selecting more than one remedy, but even being contingent. And that is to say, we'll write a decision document that says we're going to do X, and then depending on what happens, we're going to do Y or Z. Some people would think, well, is that adequate public participation? Well, the answer is yes. We've been as transparent as we can regarding our best understanding of the problem and how we're going to go about addressing it. Also, by way of background, in terms of understanding the subsurface, anybody here who has not seen Tom Sale's 14-compartment model? It's useful for understanding the subsurface, although it isn't necessarily as useful as some people have suggested for selecting remedies. But the idea is that there are both in the sources, there are both low permeability and transmissive zones, and similarly in the plume, and that there's different phases in which the contamination occurs. And because the subsurface is dynamic, you can have changes over time, both prior to, during, and after remedy implementation. There's another concept in terms of this understanding the subsurface that I wanted to share this morning, partly because I want to disabuse some notions that have been out there a little bit. It is useful, especially at these DNAPL sites, chlorinated solvents, which I presume is the bulk of most of your folks' work here, although some of you may be doing underground storage tanks as well. But Chuck Newell and others have suggested that there's 3 stages of a NAPL site: the early stage, where there's a lot of NAPL; a mid-stage, where a lot of the NAPL has been depleted and most of it is either in low permeability zones or in the dissolve phase; and then a final late stage where there's basically no NAPL left. I'm okay with that. One of my concerns has been that there have been too many cases where people have said, oh, I've got a late stage site. The NAPL's all gone. Well, maybe, but you adopt this attitude at your peril. And as Jeremy was just saying, we're still, unfortunately, in some cases, selecting pump and treat remedies at sites where we're pretty sure there's some non-aqueous phase liquid. Again, if you're all about annuities and being able to send your grandchildren to college, well, maybe that'll work. But as a intelligent or thoughtful remedial strategy, it has its limitations. So again, it's important to note that the contaminant location and its architecture is not just a function of time. I do a lot of wood treater work in MGP sites. Some of those sites haven't produced anything for 100 years. and there are still considerable quantities of DAPL that we're having to deal with. So the attributes of the contamination and the subsurface hydrogeology. So I'm not saying don't look at your sites and try to understand them as a function of those stages, but just don't think because that dry cleaner shut down 40 years ago that all the NAPL has been transitioned into different compartments. Again, there's been a sea change, and as I say, every 2 years I'd go to Battelle and it'd be like a 20% increment in the use of more than one tool, although I'm not sure we were as sophisticated as we could be in the use of those tools. So we have a much larger toolbox, but more importantly, and again, among the reasons I was such a proponent of thermal was that people were measuring something. You could measure the temperature, and if you got the temperature consistent with that contaminant's boiling point, kept it there for a while, you could be pretty sure that you'd gotten what you needed. And a lot of the ISCO vendors will tell you that probably before about 1998, they were mostly in the mode of dump and walk or pump and pray, but they've all caught up. And those of you who've done any ISCO projects are probably aware that they're monitoring DO, ORP, conductivity, permanganate, you might monitor the purple. So again, across the board, at least in the projects that I deal with, we've gotten much better at process control. Also, as the previous two slides illustrated, we also understand the subsurface somewhat better. And again, as Fred Payne will be speaking here today, as Joe Quinn and his colleague has said, the idea is to talk about return on investigation. Even in my regional offices, people are reluctant to punch a bunch more holes for reasons that are regrettable but understandable. But it is possible to sell the idea of high-resolution site characterization as a way to, again, at the back end and at the end of the day, the overall cost and the confidence of the remedial action should be enhanced. But again, certainty persists. I work, again, sites 10, 12 acres. Some of our sites, we thought we'd pin cushion them, but we're still finding out that you really can't punch enough holes. And Paul Johnson, and by the way, there is at least one example of an environmental remediator who made good. Paul Johnson used to be a dean at the Arizona State University. Most of his work was remedial engineering. He's now the president of the Colorado School of Mines. So I know of at least one environmental remediator whose past did not haunt him into his future careers. Also, and as you'll get a lot of good information from Rick Kramer, Fred Payne, and Murray about site characterization, but and I think I've got it on another slide, but I think, at least in my mind, we're coming to understand how important geology is. There was a time when I think there was a bit too much emphasis on the chemistry, and now we've come to understand that if you're really trying to understand the nature and extent of your contamination problem, you need to get into the mode of understanding things like sequence stratigraphy and how the geology affects where the contamination is and what you need to do about it. As perhaps the most important point, and I'll cover that in a bit more detail today, when we started this combined remedies thing, we've probably spent 6 hours on the conference calls with an advisory panel trying to come up with a better name. I mean, would you march off to a crusade with something with the word combined remedies on a banner? Not very impressive. But more importantly, it's as important how you go about implementing your tools as which tools you use. And we've struggled mightily trying to come up with a more attractive and encompassing term for what this collaboration has been about, and we really haven't succeeded yet. Six-pack of beer if anybody's got any great ideas on what we should call this crusade. Again, in terms of thinking about combining remedies, this is probably pretty obvious to most of you. You can combine them temporally, spatially, and then a new, not new because it's been around a long time, but seems to be becoming increasingly interesting across the board is the idea of package deals. Because it is true that when you're having to lash different technologies together, either spatially or temporally, it gets more complicated. If you have a tool or a technology that has multiple mechanisms of action, so you really have to only go out and do one injection or one series of injections, your life is simpler if there are multiple mechanisms of action that you can take advantage of from the use of one tool, and I'll talk about that a little bit more in a minute. Also, both Jeremy and I have referenced it, but again, from an EPA perspective, as I'm encouraging my RPMs now to write these sorts of toolbox approaches into our records of decision, what you'd like to be in is an anticipatory and intentional mode, right? You want to, it would be best if you think you understand your site well enough from the inception that you build that into your record of decision. And again, I've got some examples of that. And then also providing for mid-course corrections. And that's becoming the norm. People understand that the subsurface is dynamic and will change through the course of the remediation. But unfortunately, we've got a lot of sites that I call type 2 sites, where people have tried something and it didn't work, and say, okay, well, what do we do now? But more importantly, I don't know what the right number is. I think we've got something like 600 pump and treat systems, many of them dating back. Jeremy was talking about Germany. We've got sites that have been pumping and treating for that long. In that era, nobody even really understood. We were either in a state of DNAPL ignorance or DNAPL denial. I don't know that anybody's ever done an analysis, but some proportion of those 600 pump and treat jobs probably have NAPL. And somebody someday may get around to wondering, well, maybe we ought to think about doing something else. Again, not an exhaustive listing of the kinds of technologies that can be combined effectively, and we've seen almost all of these. Interestingly enough, those of you that are familiar with the ITRC, they put out a document a few years ago in which they tried to say, okay, which technologies could be lashed together and which not. At that time, they said, well, basically, you probably shouldn't do ISCR and ISCR. But I know of at least 2 sites where through appropriate modeling, an ISCO vendor has implemented a technology that involved not only an oxidant in the front end, but then a permeable reactive barrier at the back end. So again, something that ITRC at one time said don't try to do is now becoming at least something that has been done at full scale. Also, even though we talk about this combined remedies thing, it doesn't have to be particularly exotic. In fact, I've done a number of these workshops or seminars at the Patel conference, and Joe Rasabi from Redox Tech gave a nice presentation in which he talked about setting up your next site, or next shot. And I was on the Regenesis website last night and saw one of their examples where they suggested, and again, I've seen a lot of this, where they've suggested putting ORC in the hole after you've yanked the tank. I mean, well, why not? Unless you're absolutely sure that you've got the whole periphery there, why not put some ORC in the ground? I know of a couple of other projects where they got this big empty hole in the ground. They're pretty sure that there's something beneath that, and maybe they ought to, after they're going to do their monitoring, groundwater monitoring for how many ever quarters you have to do it, maybe we're going to have to go back and do something else. So they've installed piping and then backfilled. So if they then have to go in and put something else in the ground, they basically set up their next shot in terms of what they're going to do. Interestingly enough, when M&A first came along, because I was in the technology innovation business, I thought, well, there goes the game. Nobody will spend a nickel anymore on innovative technologies. Well, it turned out that M&A was our friend, because no longer did your tools have to be perfect and a silver bullet. They just had to be good enough. But I'd say most remedies today, especially remedies that have plumes involved, are going to have M&A as a component at some time in the remedial process. Now, there are some concerns. One, of course, is the dreaded DCE and vinyl chloride stall that can occur. And many of you may know that vinyl chloride is at least as bad as the parent compound. Similarly, and I still see this a bit from some of the things we get from responsible parties, they think they can go straight to M&A. Well, the guidance that we wrote 10 years or so ago said, we really think that if you want to go M&A, it would probably be preferable or desirable for you to do something about the source first. One of the things that, again, as I talked about, as the toolbox has gotten better, is back in the old days, we'd look for things like plume stability or concentration declines as our main indicator of whether M&A was happening or not. Boy, there's a lot of tools out there now. In fact, Patel has a whole conference, right, devoted just to biological treatment. qPCR, PLFA, the new QuantArray, in which you can determine not only whether the bugs are necessary or there, but also whether the necessary genes are there and whether they're expressing those genes with the necessary reductases to actually destroy the contaminants. And if any of you folks used a biotrap, again, I meant to put a picture in here. I think that is really a cool tool. I'm a tool guy, as I may have already reflected in my remarks. It's basically a cylinder with slots, and you put a Nomex bead in them. You can do a myriad of things to determine what's going on. But what I really like about it, as opposed to having to try to do lab studies with all of the artificialities that involves, you can actually stick these biotraps in the ground, thereby taking advantage of the natural hydrogeological and geochemical conditions, and then pull them out. So anyway, I really think highly of these biotraps as a tool for both site characterization and monitoring your remedy. Also, interestingly enough, M&A is a natural combination. When it first came along, the thought was it was mostly biotic processes. But more recently, and the Air Force has done a lot of work in this area, is the idea that there's also abiotic mechanisms, that the matrix is not necessarily defenseless, that there's enough iron and other metallic species in the ground that they can also contribute to reductive dechlorination processes. Also, there's this idea of magnetic susceptibility, and John Wilson, who was one of our luminaries at EPA and since retired, we were doing some work up at a site in New York where even though the TCE levels were less than 100 parts per billion, we were still seeing MCL exceedances and vapor intrusion issues. But by trying to conduct some testing for magnetic susceptibility, we're trying to determine whether abiotic processes may be helping us out. Also, there's this new idea, or not that new, there's some ongoing work in this area where it's actually, there's a number of names for it, but one of them is biogeochemical transformation. But the idea is that the bugs actually potentiate the metallic species. And as they're passivated, the bugs then come back in and pump them back up again. So again, there's a number of companies that are trying to make a commercial application of that technology. Also, by the way, as early as 1992, people were writing articles in peer-reviewed journals about the idea of enhancing bio by chemical oxidation. Vipul Srivastava, now with IGT and some others, had the idea of sequentially using biochemical and then bio. This would be mostly for PAHs. And then Mark Zappi, who used to be with the Corps, wrote a paper or presented at a meeting in 2002 on chemical oxidation priming by biological treatment. So anyway, there's a history of doing this sort of work. The Navy did a report a few years ago, 2007, looking at 5 ERH projects. And this actually goes to the package deal approach that we talked about, even though ERH is thought of as one of the bigger hammers. But anyway, the findings of this report were that in addition to the volatilization and steam stripping that you get with ERH, they were seeing enhanced bio and abiotic reactions at all 5 of those sites. So the idea is take advantage of those sorts of mechanisms. Understand that it isn't just one thing going on, but other things may be happening. Hydrolysis is another phenomenon that perhaps can be employed. And I think I've got a slide in a minute. One of the ERH vendors is doing a project at one of our sites up in Tacoma, Washington, where they're calling it heat-enhanced, I'm going to get it wrong, David. Pressure's on. Heat-enhanced plume attenuation. I get it? All right. Anyway, the idea is instead of heating the site and getting all of it with ERH, they think they can save quite a bit of money by just heating to 30, 40 degrees centigrade and then potentiating the bugs to help out. I've got another slide on that in just a minute. Synergies, exploiting them. That's something that we're not doing as well as we could, but both ISCO and thermal remedies release a lot of bioavailable dissolved phase carbon during the course of that remediation. So if you're also dealing with the plume, think about what can I do to phase my follow-on remediation to take advantage of the dissolved carbon and the warm water that may be flowing down gradient through that treatment zone. And again, this heat-enhanced bio is underway at this well 12A in our Region 10 office. Let's see here. Slide on a project reflecting some numbers from the previous slide. Dissolved phase carbon before the treatment and post-ERH, and there was a 40-fold increase in the dissolved carbon going down gradient. Chemical oxidation vendors are actually morphing into Chem Plus Bio companies. One of the Regenesis products a few years ago, their design manual said that chemical oxidation is best coupled with accelerated bio. Bingo. FMC, now PeroxyChem, also has a closure CR product that they talk about that couples chemical oxidation plus enhanced aerobic bio. And again, some more package deals. There's an ABC Plus product that adds ZVI to their ABC mixture, thereby promoting both anaerobic bio and reductive dechlorination. Again, as I've said earlier, how you do it is at least as important as what tools you use. And it is true. I've used these two quotations so often. One of them's mine and one I stole from somebody, and I can't remember which is which. But it is true that because we can't punch enough holes, when you implement your remedy, that's just as important as the next phase of site characterization. It is true also, and many of you who've done ISCO projects have learned that, okay, you're probably going to want to do more than one injection, but if you're paying attention, your subsequent injection should have a subsequent footprint, or a smaller subsequent footprint. Also, paying attention. The AECOM folks put on a nice webinar a year or so ago. They were installing an ERH system, and they were installing the electrodes to the top of the bedrock. Well, in the process of doing that, they learned that the topology of the top of the rock was much different than what had been originally portrayed, and all of their planned groundwater monitoring wells would have gone in the wrong location. So again, the process, by paying attention during the installation of the remedy, they were able to modify their groundwater monitoring regime. And again, I've talked enough about in situ process control. And by the way, that's what we're looking for when we get packages in from PRP consultants. Besides using the right tools for the right problem set, what are you doing to control your process so you can have a good chance of succeeding? I told Jack I was going to steal this slide. If you think about it, of all the remedies that we use, you would think that bio would be among those that you need to be the most attentive to, right? Because it's dynamic, or as or more dynamic than any of the other remedies we use. And I don't remember what conference or webinar Jack said this on, but I really think that it's important that, again, that you do your microbial evaluations throughout the remedial process. Because as we're coming to learn, most of the bio that's happening is a consortium of bugs. And as the geochemical conditions change, you're going to see alterations in those consortia. I found this when I was trying to do some research on biofilms, which I don't think we've done as much work in as we could. And as I say, this is so old, this is before computers, so I couldn't really cut and paste. But the bugs, among the things that they're doing is that they're doing all kinds of things in the subsurface. Changes in pH, electrochemical position, lead to abiotic degradation. In fact, there was an article out of the Smithsonian recently that suggests that many of the minerals that we have on the planet Earth didn't occur naturally. That it's actually a lot of the mineralization that we see was because the bugs have been working on things. Just fascinating. What are some of the remaining challenges? I still get some people who, especially some of the more recalcitrant PRPs around, they still want to argue that even you address the source and maybe do something about some of the warm spots on the site, you're still not going to affect the longevity of the plume. I think those are based on simplistic models, but I do admit that we do need better tools to predict resource restoration timeframes. Then we can stop having these arguments about whether you can kill the plume or not. Also, again, we'll talk about it a bit today, but I think there's still work to be done on delineating the boundaries and the temporal transition points of how much to heat and how much to eat among your remedies. I think I've got I got a few minutes left. I got till 9:30, right? Cool. We'll have some time for questions. Most of your speakers this afternoon are going to be talking about case studies, but I thought I'd share a couple with you that were particularly noteworthy, just again to show you that if EPA can do it, you can sure do it. This was a project that I actually came out here and participated, supporting the region in a very contentious public meeting in Maywood. In fact, Tim Garvey was one of the lead consultants on this site and did a very nice job for us. We chatted this morning. He's not going to talk much about this project, but this was one of our, it was a classic solvent recycler. They yanked all the tanks out. We didn't find as much mass as you would have thought would have been there as a result of all these tanks, but so it goes. There were multiple components to the remedy, dual phase extraction for the shallow zone. There was a tight zone between 35 and 100 feet where it wasn't going to work to try to either get it out through dual phase or pump and treat. So we did resistive heating, and because of concerns in the community among some activists about dioxin formation, we brought in a flameless thermal oxidizer for the off-gas treatment system. Project went well. And then for the deeper zones, we were doing, around the outside of what we call the Danish or the donut, we were doing enhanced pump and treat. And then now the plan, and again, maybe Tim can speak to this briefly because I haven't stayed up to speed on the project, but the idea is to do some enhanced bio for the downwind cross gradients. I've also heard, by the way, that life is unfair and then you die. It looks like there was some sources up gradient maybe that we didn't get completely. Is that right, Tim? Yeah, so anyway, but at one time the groundwater data was going in a very nice direction for us. The ERH has been completed, and as I understand it, they're doing lactate injection, but as I say, I put this slide together before this new information that there might have been an up-gradient source. Another very interesting project, a dry cleaner we were doing in Grants, New Mexico, and I've emphasized a contingent rod. This rod was written in such a way that we were going to do in situ thermal, and by the way, that's completed. But then, depending on how some follow-on pilot studies came out, we were either going to go down the in situ chemical oxidation or a reductive dechlorination pathway. And it turned out, because ERD can be a bit cheaper, I suppose, in some applications, that's what they've used for the follow-on remedy. But this, by the way, we have a remedy review board that if a remedy's over a certain cost, they're supposed to review and make sure everything is copacetic. This gave them a little bit of heartburn to write a record of decision in which we weren't absolutely certain about each of the components of our remedies. But as I explained to them, as we understand the uncertainties in the subsurface, it really is important to be flexible and adaptive and to portray that in the decision documents. So again, there is an example, at least for EPA, of writing a document where we weren't exactly sure what we're going to do, and we've been able to satisfy the public participation interests of the agency. And one quick last project, again, one of my earliest slides said you can combine just about anything. Your imagination is your only limit. Orlando Magic, we're building a new facility down in Orlando. This was a guaranteed fixed price project. 50% of it was at risk if the MCLs weren't achieved, and they did in fact achieve MCLs. The idea was to use peroxide, which many of you know is about the cheapest of the oxidants we can use, and it's strong, and then permanganate, because again, they were trying to get to and maintain MCLs for a specified period of time. And then, again, ideal world, right? You dig up the source, and then you go after it with some things to polish. Well, again, life is unfair. This particular project, they found the source toward the end of the project. But again, they kept looking, because again, MCLs or bust. So it was cost effective for them to keep looking, even as they were progressing with the other phases of the remedy. Again, they used catalyzed peroxide, first phase, then permanganate to polish. And then, as I say, they found a couple of small areas, 900 cubic feet. You find the drain last, and then you go on. Okay, I think I'm just about done. But here's where I think we're trying to get, and the whole idea behind combining remedies. Again, even though I'm a big hammer guy, I don't think we should use them more than they're absolutely necessary. So the idea is use your big tools, your big hammers, adequately to address the sources. Then have some way to transition to some cost-effective polishing steps, either spatially or temporally. And again, thermodynamically, pump and treat is just, and even from a sustainability standpoint, it's energy intensive. So the idea would be to reduce or eliminate the need for pump and treat. And then, as I said in one of my earlier slides, to be able to rely to an appropriate extent on monitored natural attenuation.